These are lab procedures. It's got a lot of information in here that hopefully should help it go smooth for you and me. All lab grade form entries must be completed in pencil. I got tired of following road maps a long time ago. An example of completed lab grade form is provided on this. Before starting each lab, obtain a blank lab grade form. They'll be in a box up here. In fact, let me show this. And the lab grade forms will be in here. And it'll be up here, a step here on this page. Fill in the required information at the top of the lab grade form for starting the lab. Only get one lab grade form. I go back here and there's 5 lab grade forms back there, and I don't know which one to sign. We're trying to make this thing run real smooth, so everybody gets my time when I sign these things out. Lab grade forms do not leave the lab. This is your official grade. You got, and I've signed all this stuff up, and you take it home and look. So if these things stay here, that means there's no chance that they'll get lost. Check the instructor's lab manual for corrections or modifications. Document any changes or additions in your lab book. Write your name on the title page of the experiment. And we do that because we're going to staple the lab grade form to the lab. You're going to turn in the lab and the lab grade form, and it's stapled on there. And every once in a while, the lab grade form gets tore off because it's stapled on there. And now I don't know what lab grade form goes with what lab. Does that make sense? But if you put your name on the lab, then we have no problem with that. All the PLCs used in the lab are not SLC 500 series. We don't use the SLC 500s anymore. Even though we probably could fire it up and see if we could connect to it. I guess it still works. And we got about 6 or we got, I think, 8 of these. Most of them over Building A, but we're going to use it for show or tell. You will either be assigned a Micrologic 1000. Of course, in this class, it's so small that we gave everybody a Micrologic, or let everybody use a Micrologic 1100. When entering information about the PLC, mark out where they list SLC 500. So the lab book was basically written for the SLC 500, or what most people call the SLC 500. And enter the information about your assigned PLC. So we've got a Micrologic 1100. So every time you see the SLC 500, you need to mark it out and make sure you put in the Micrologic 1100. Trainer provided toggle switches, push buttons, or selector switches will be used as inputs. There are no motors on the provided trainer. When a motor is specified, turning on an output port light will stimulate running a motor. Does that make sense? Yes or no? Because we would use an output to energize a relay to run a motor. And I'll show you something. All drawings must be made to industrial standards using the correct symbols. Use the symbol specified by the lab activity instructions when drawing a relay logic diagram. So basically, we'll start off by drawing relay logic, and I think we're going to drop back and actually change that over to all the diagrams we'll do in this class is going to be for PLC logic. So the way the book teaches drawing, coming up with PLC programs is the way we used to do it when we wrote programs for computers. I thought did I explain the process we used to go through a long time ago? So, we had a computer and it was a mainframe, and and we had all these dumb terminals that everybody would use. And you had to enter the computer at the mainframe. Well, the primary way of entering a computer into the mainframe was through what we call cards. I forgot what you call them. These were cards that looked like this at an offset corner, and they dropped down, and you had all these rows. And then you would punch dots into the hole through it to indicate the program. So you had a key punch operator. So the programmer would write the program. They would give their program to a key punch operator. The key punch operator would sit there and type it in, and it would translate it over and punch it into these cards. And then they'd take the cards to the computer operator, and the operator would run it through the card punch reader, and it would enter that into the program. He or she would try to compile it, and if it got any compilation errors, he or she would send that information back to the programmer, and the programmer would redo it. So what they would do in PLC, and that was just what they would do with PLCs. First of all, they'd say, okay, if you can't do it in motor controls, then it's not going to work. So what they started doing was taking diagrams written for ladder logic, relay logic programs, and converting them over to PLCs. So that's what this guy does. He's going back to old school. Now what do you do when you program? Anybody ever did any programming? What do you do? Yeah, you just flop it right into the thing, see if it works, right? You understand? Try it out, see if it works. And that's the way we do it now. So the programmer is the programmer. They actually enter it, they download it. And that's even true when they write programs for iPhones, or they write programs for any type of computer. The person programs directly. So what we used to do was we used to use flowcharts. So we had all these symbols in a flowchart, and that's what function chart diagrams is a lot like a flowchart. You do that programming. Before you even wrote a program, you develop a flowchart for a program. If you couldn't get it to flow in the chart, it wouldn't do what? It wouldn't flow in the program. So it was pretty interesting. That's kind of like this guy's doing. Develop the relay logic, take the relay logic, and then develop the program from that. But we're not going to do that. But when you draw your diagram, it's going to have to be the industry standards. So basically, you're just going to copy what you programmed into your PLC. All PLC input-output connections must be drawn for your assigned PLC. Mark out the 120 volt. So the way it's in the book. Let me see if I got this on the slide here. And this is not even true for SLC 500, so this guy's kind of, and it's a good book, and we can modify it. It's hard to find real good PLC program or lab books anymore. So, I think this is no, that's not it. I'm trying to find a drawing of the way it is in the lab book. Has everybody got their lab book? You don't need it today. You definitely need it next week, because we'll be in lab all next week. So this is the way all the diagrams. So what you're going to do on yours is you're supposed to come up here and draw this. Well, we don't have 120 volts on ours, and so ours is wired like this. So what you're going to do is you're going to mark out this, and this is the way ours is wired. So we have a DC power supply right here, and this is the symbol for a DC power supply. And then what you do is you're going to drop down, and then you put a line down like this. And this is our common. And then for everything we do, like if I do go, I'm going to put a push button, we would put it like this. So this is the way our inputs. And this would be input 0, 1, 2, 3, 4, 5. And of course our input's actually in here. Our input's actually in here. So the highest input that we have on our PLC is 9. And we're only using 8, so we never need them anyway. So this is going to be, and this is plus 24 volts. Now this is okay. That's the problem on our lab books. Over here what we do, the DC voltage source is pointed this way. And then we drop down with our common over here. And then we come over here and use the symbols. Now this is where you're going to have to use these symbols right here. So these are the actual symbols of the electrical devices that we have connected up there. So you're going to have to learn those symbols. Okay? And this is what this PowerPoint's talking about. So you're going to mark off the 120 volts and you're going to draw the power source right here. Are we okay? Yes or no? So this is the way our PLCs are wired. And over here we don't have, in fact, our outputs stop at 6. But that's plenty for what we do in this class. So that probably makes sense. Hopefully that makes sense now. So you mark out the 120 volts and draw the symbol for the input-output power source used by your assigned PLC. The 1000s, the little fixed PLCs, do use 120 volt AC outputs. So that's why we try not to. Well, we don't do any wiring in this class anyway. Symbols. When drawing the I/O connections, use a symbol for the device specified in the activities instructions. They'll start off giving you the symbols. In fact, the first lab program you put into the PLC, they actually give you the program, and then they'll give you the relay logic, and you'll develop a program from there. And then toward the end, they just tell you what the program's supposed to do. And that's true if you take ILT 196, Advanced PLC. All they give you is what the program's supposed to do. And then you come up with what? You come up with your logic. So if I'm going too fast, y'all let me know. The lab book is split into lab groups, contains one or more activities. A lab form is required for each lab group, not activities. Do not use the same lab form for multiple lab groups. You understand that? So when I come up here and look at this guy, okay, so here's my lab book. So this says lab 1, activity 1. So here we got this. So this one we have no problem. And take these data files 6-1. So that's a lab. That's not going to be. So right here. So here's 6-2. Here's activity 1. Okay. Here's activity 2. So this is going to be on the same lab form because it's still lab 6-1. So when we look at the lab form, you'll see I have multiple places where we can grade each activity on the lab form. So there's 2 activities in that lab right there. Oops. When you get here, you're going to mark at that. You're going to put the DC power supplies on here, right? Everybody okay? Here's lab 6-3. Now, this is one we're not going to do. Unfortunately, this is the only lab book we got. And originally, when they came out with this series, they gave you a copy of this Logic Pro software. It came on a CD. And it was unlimited use, but you had to have the CD in the computer to run it. So what they did is, and the problem is, and I don't even know why he or she did this, is that he's got the lab for the PLC, and then he's got the lab for the same lab for Logic Pro. I guess he just wanted to make the lab book real thick. So we're not going to do any of the Logic Pro. But, now some of them we'll have to figure out, but, you know, they're the same lab. So this is a Logic Pro lab. Might have tore some of them out. This is not. You'll see how it's, so activity 1, activity 2. The most we'll ever have is 3 activities. And each activity will be on the same lab form. And this will be turned in as the lab. So the lab number is actually 6-6. That makes sense?
If I found a copy of Microsoft for Logic 500, and is it compatible with 500 that we have?
If you got it's RS Logic 500. If it's a full-blown version, then.
So if I just went in and saved it and then brought it here.
And saw if it worked, yeah.
I found an old split that was no longer being used.
Oh, really? Just the PLC, right? Well, technically, you don't have to have the PLC to write the program.
Right.
You need the PLC to try it, but you don't need the PLC to write it.
My boss said, well,
Sell it for parts. So y'all understand that now? And when we get back to the lab form, it'll make a little, when working in a team, teams must swap program and assistant position. We don't have to worry about that. The class is so small that we're not going to work in teams. Place a check mark beside each experiment procedure step as it's completed. That just helps me know where I'm supposed to be signing off, and I don't have to figure out, right? If working alone, name each PLC program with the lab group. So this tells you how you need to name them. Working alone, name each PLC program with the lab group number, activity number, dash activity number, followed with your initial. For example, Bill or info, file name. For the lab 5-1-1, what lab number for the lab group for activity 1. Working in a team, we're not working in a team, so we don't have to do it. It's basically the same. So that makes sense. When you need a lab sign-off or help, write your programmer's name on the sign-off sheet. We won't do this unless it starts getting, you start having problems with how the order is. So we like to go in the order that people's ready. And I found out we have some people that are kind of shy and they don't want it, and they think I'm supposed to check on them all the time. So yeah, we'll go ahead and do this. So there'll be a sign-off sheet up here, and when you're ready for a sign-off or you need help, then just put your name on the sign-off sheet, and I'll go down that sign-off. You call me and I'm gonna say, well, is your name on the sign-off sheet? Cause I'm gonna go down the sign-off sheet. That's the fairest way I know how to do it. And that way everybody gets my time in order. Besides for your name, place a check in the appropriate column, indicate if you need help or a circuit sign off, and write your station number. We're going to have to do that. So in here we know, I know everybody's name, so just put your name on there. We get big classes and so you can't ask for help and get an instructor sign off at the same time. Ever demonstrate your working PLC program. So when you go through your lab, that's going to be one of your steps. It says demonstrate your working PLC system to the instructor. Procedure step. You are, and you're confident that the program is working as prescribed. So we don't just come in here and just key stuff in. We check it out. We make sure it's working as prescribed, what it's supposed to do. Have the instructor check your program and initially your lab book and lab grade form. Before the circuit is checked off, questions will be asked by the instructor to understand the program's operation. Programs that are not checked by the instructor will have to be reprogrammed in order to receive partial credit, and a deduction will be made for not following instructions. A major deduction will be made on labs turned in without an instructor sign. I've had that happen. Somebody gets behind and they just throw stuff in, they write stuff in their lab book and they turn it in. Now, I've never seen the program. In big classes, that usually happens every time. Now you understand that? Next week might be a little unique. We're going to have to plan for that. I'm attending a training session myself next week, trying to get a certification, another EC3 certification. And it's all next week, Monday through Friday, Monday through Thursday. We're going to try to set it up where we can get ready so y'all can have a big lab to do. Hopefully I can get Miss Wilson to come in here and she taught PLCs for a long time. And if you could just sit in and sign these labs off for you. Once you complete the lab group, remove the completed experiment group from your lab book. If you got a lab book, things are perforated on the left-hand side. You can these pages out. This is why you don't want to buy a used lab book, by the way. Because odds are all these labs are going to be what? Gone. Unfortunately, I don't know if this bookstore buys them back. We had our loss of state. I told the guy, bookstore don't buy these back. That's all they'll have to be gone. Remove the completed lab group from the lab. Place the pages in the correct order, beginning with the lab grade form, and then the lab, the page followed by the pages that contain all the information about the activity. The lab title page must be included in the packet. Staple the packet in the top left-hand corner, and place the packet in the box up here that's going to be labeled ILT 194 labs to be graded. This box will be located on the lab bench at the front of the table. It'll be over here on one of these pneumatic trains. Do not forget to write your name and the space provided on the lab grade form and the lab experiment title page. You probably won't have that problem because when I come back and check the lab, I'll be looking for that. This is not required until you turn it in that title page. The first few discussion pages do not need to be turned in for grading. All pages that contain instructor sign-offs or student written information must be included. Make sure pages are stapled in the correct order, lowest number to highest. You'd be surprised. I get these labs turned in, they're all over the place. I don't know how I wonder if we got some students that don't know how to count. Do not staple multiple experiments together. So you got one lab, like 6-1, all the activities, that's gonna be one lab. You're gonna put them in the right order, you're gonna staple a lab grade form, and you're gonna turn it in. You're not gonna staple multiple labs together. And I get that all the time too. And then I gotta take them apart. The completed experiments must be turned in with all required information and drawings at the beginning of the next class meeting after all assignments programs in the lab group have been signed off by the instructor. The lab grade will be judged by 10 points for each 24-hour period of the lab grade. So I got on a lab grade form. When you get the last activity signed off, I'll turn that in. Some people turn it in at that. Some people want to go in and look over things before they turn it in to be due at the next class. That makes sense? Okay. What happened? Where am I at? Homework labs, relay and PLC ladder logic diagram drawings, and IO assignments are not a team effort. It must be completed individually by each student. Do not copy answers from any book or from another student. Copying will result in 0 scores for all parties involved. I have never understood why people cheat in the major they're in. Never understood it. I mean, it's cheating is one thing. I mean, English and math and stuff like that, okay, but in the discipline you're trying to learn, cheating is something you're trying to learn to do. I've never understood that. Do not staple multiple lab groups together. That's about the third time that's been there. Once you complete a lab group, remove the completed. I've already done that. Required information, completed labs are to remain in the instructor's possession during the entire term. The completed lab assignments will be returned to students during the first week of the next semester upon request. Labs not claimed will be destroyed. All I need to do is keep the lab grade form, because that's your official grade. So here's our labs. So lab 1-1, 2-1, 3-1, 4-1, 5-1, 6-1, these are homework labs are due within 7 days after the lecture on these chapters. Lab 8-1-1 and 9-1-1 are required labs. Non-completion of either of these labs will result in an incomplete course until both labs are complete. So this is going to tell you exactly what labs. They're telling you exactly how they work. These are telling you which ones are homework labs. So lab 1-1, this is going to be done here. So this is where you're going to look at your PLC and figure out things. So we're only going to do procedure step 1, 2, 4, 6, 9, 9. For 54. A selection of components and communication. This is going to be done. Homework. Number systems. This is the homework. This lab is online and that's where it's located at. So all that is just where you go out and you do all these conversions on number systems. What I've done is I've taken that and I've converted it over to a multiple choice test that you can do online. So don't turn in lab number 3-1. That is where online. Everybody okay there? So 4-1, devices and motors, all procedure steps. 5-1, all procedure steps. 6-1, basic terms and data files. This is homework. So that's those data files. Those are explained in your textbook. We do it in a little more detail in the class. In 6-2, you're going to do activity 1 and 2. On 6-4, you're going to do activity 1 and 2. 6-6, you do activity 1 and 2. 6-7, 1 and 2. 6-9, you're only going to do activity 1, just an activity 1. Here you're going to do 2 activities. Here you're going to do 1. These are going to be handout labs. Okay, that's what I chose for handout 2, and up. Are you okay? This tells you exactly what labs we're doing this month. You can say, well, that's a lot of labs. Well, some of them don't take a lot of time. All these up here are homework labs. So this tells you how you're going to be deducted. When I start grading, it tells you how you're going to be points. Now this is a lab grade form. This is how it's going to be filled out. So you start off with your name, coming in and working with a partner. You're not going to be required that. You put the lab group, like 6-1, 6-2, 6-1-1. You put the name of the group. That's going to be at the start of the lab. That way, you'd be surprised how many people get these two things mixed up, and I don't know what they belong to. Here you're going to keep up with the time you've been you work on this lab, and this is just for me, but it's worth points. This is not the time, this is the amount of time to the nearest half hour. You'd be surprised how many people put the time in there. This, of course, all these will be you because we're not working in a team. And this is activities. So you put the activity number out here. None of the labs have more than 3 activities. You put the activity number. You put your programmer name, you won't have an assistant, and then when I sign them off, I come up here and put my initials there. So you have initials in 2 places. You're going to have initial in your lab book, and you're going to have initials on this thing right here. And that way, if one of them gets lost, then I know where you're at, right? Does that make sense? You're not going to write in this section right here. That's where I deduct points. And that's the lab grade form. That's what and they'll be all inside this binder opened up. The instructor's sign off for this will be on the top of this. So y'all got any questions about the lab? That was very detailed, guys. Yeah, when you get them signed off, yeah. And you write the 1 in there, you write the 2. The most we'll ever have is 3 activities. And down at the bottom, notice I have the way I take off points. So this is where I take off points. Now these are for all activities. So if you come in and you don't have the lab grade form, then that's going to count off on everything, right? You understand? Because that's the same lab. And then I do the totals over here, and then I put the percentage over here of what you actually make on these activities. Now, if you look at the activities, if you look at the grade book, that's what it's going to be. It's going to be 6-1-1. So that'll be on Blackboard. That'll be 6-2. I'm sorry, 6-2-1. So that will be what you made on this lab on that activity. So I don't put the title out there. If you look at the lab, if you look at Blackboard and you look at the grade book. Of course, I can't show you the grade book. The grade book there. So I don't put the title. So there's a column for 6-1-1. There's a column for 6-1-2. So technically, every activity is graded individually. You get points for each one of them, but they still count as they're still done on one lab form. Any more questions? No, you come up here. No, what you do is you come up here on that sign-off form. You come over, you put your name, and you put a check in to need help.
Right.
And if you do that, it's okay.
Okay. So if you respond next week and
That's what I'm trying to do. I'm trying to get Nancy to come in here and take care of it.
And does she know where she did the electing done?
Oh, yeah, she did the,
Okay, so we asked her the same thing.
yeah, she knows the RS Logic 500. Probably not better than me now. I mean, I played around with it, but she taught the class a long time. So we had, when we first started, I asked her a lot, especially as far as, you know, the communication setup and, so any more questions? So we follow this. If we do this, lab goes smooth. And we have no problem. If we don't do this, then we end up with a mess. We don't end up getting as many labs done, for one thing. So if you got all this in place, so if I come back there and you don't have the information filled out on your lab grade form, I'm gonna take off points because now I'm waiting on you to fill up that information and somebody else is waiting on me when you should have already what? When you should have already had it done, right? Does that make sense? We'll start off being pretty slack to start off with. But after next week, probably I'll give y'all a couple of days after that. Nancy will be trying to do this because I got to talk to her. We'll try to figure out how we're going to handle next week. That's what we're going to try to do. We're going to try to figure out how we're going to get through this, and we're ready to do quite a few labs. So, oops. So your first programming lab is actually 6-2. And then this other stuff, we're going to try to get this today. We're going to look at internal relays and talk about those. And we should be able to get through these labs. This one, you're going to have to look at your PLC. This is not the EduTrainer, guys. This is not the EduTrainer. This is your PLC. So this will happen every time. I say, how many inputs does your PLC have? They look at the EduTrainer and they say 16. This PLC does not have 16. The EduTrainer, which is the mount, by the way, if you didn't know what I'm talking about, that's the mount. That's the white mount. It can support a PLC with up to 16 inputs. And it can support a PLC with up to 16 outputs. But that's not how many your PLC has. And what in the communication standard, we've already talked about that several times. The speed. So let me show y'all that real quick because that is one of the questions. So they're going to ask you how fast is the speed of the communication. So I'm going to bring up RS Logic 500. Nope, I don't want to do that. Oops. So we have two ways we can send information. We can send it parallel, which means every data bit has its own conductor. Or we can send it serial, which means we use two conductors. We always got it. If we're using electricity, we got to have two conductors, right? Everybody understand? What would be the advantage of parallel over serial? What's the advantage of, so I'm going to Birmingham, and we hit some lane, some sections of the interstate that's 8 lanes wide. Then we get on those country roads going down toward the river, there are only 2 lanes. I can still get 1 million cars from here to there. So what's the advantage of parallel over there? See, yeah, we can send more information in a short amount of time because you're doing it at a time. So the data buses and everything inside of the computer, these are parallel buses. The address bus is parallel bus. What advantage? So what's the advantage of serial? Starts with a C. What does that say? And what we're dealing when we're dealing with I/O devices, we're dealing with how fast can the devices themselves operate. So it'd be stupid to use a parallel bus, right? A parallel bus to do all the things to control a relay or something like that, right? Understand? And then plus, sometimes we just flat sacrifice. So hard drives. The fastest a hard drive can spin that platter without slinging it apart is 7,200 RPMs. And we got parallel ATA, which can send billions of bits per second, but the hard drive can't even keep up with that. So the hard drive finally went to a serial interface. We call it serial ATA, which is a screening interface, but it would not be as fast if it was parallel. And sometimes it's just prohibitive to do it that way. So I don't have 100 channels in my TV. So yeah, I could bring in 100 cables in the back of my TV and we could do IMAX TV. I mean, we could really, really send that. But we sacrificed, right? You'll understand that. Networking. So networking, Wi-Fi, is that parallel or serial? Serial, it's serial. One antenna, guys. Everything's going on one antenna. Everybody's on it, tries to get on it at the same time. Ethernet is serial because now the cost is just prohibitive to try to run parallel on something like that, right? Think about all the Ethernet cable we have running in this building. And if we did, so we sacrifice a lot for serial. So the biggest advantage of serial over parallel, of course, is what? So why use parallel to go to that PLC right there when all I'm doing is what? Downloading and uploading programs. So we are using a serial interface. We're using the old COM ports. And this is, I'm going to come up here and look at port settings. And this is what our PLC uses. So I'm sending 9,600 bits per second. It's using 8 bits. It's using no parity. It's using one stop bit. The layout. The way RS-232 works, it's really interesting. It uses, we'll have to do that. Used to it would use plus 12, minus 12, but anything above plus 3 and minus 3 was legal. That's why we can get by with it on USB. Then it stayed down here all the time until it sent data. And then when it sent data, it dropped from here up to here. And for 1 bit time, and that's what we call the start bit. And then it would start seeing the data that you can see. And then it would do one stop bit, 1 or 2 stop bits to tell the receiver that it had received. And by the way, this was a 1 and this was a 0. So don't always say a positive is a 1. So that's what the stop bit. Start bits are understood. We can specify the number of stop bits depending on the and then we have flow control, which added more lines. We can do what we call hardware flow control, which means we actually use wires in our cable to tell it when it was good or bad and stuff like that. Or we can do what we call software flow control, which means we send codes back and forth to the computer. So if you looked at the ASCII code chart, some of them was NAC, not acknowledge, so that would be using what we call software control. Hardware control would be faster, but sometimes faster is not needed depending on the interface. So we're using 96 terabits per second, 8 data bits. We're not using parity. We're using one stop bit, and we're using a software program. So that's the way it sets up the serial port. So every one of them is going to do up, and this is what we're using. We're using what interface? I've told y'all several times. What standard are we using to transmit the actual data? So when it sends us packets or when it sends us information, it's going to have to be coded in something that the PLC understands. Yeah. DH-45, which is a peer-to-peer. What does that mean? It means computer to computer. We can't network them together. It means computer to computer. So it's a peer-to-peer network. So we couldn't connect this PLC to that PLC to that PLC and have them communicate with each other, which is okay for this class. So that's one of your questions, guys. The communication standard, the speed of communication, and everybody in here does the same thing. I know I've shown y'all that before, but most people forget that. And it's serial, because it don't have to be what? Don't have to be fast. Most communication between PLCs, and, it's done in serial. I mean, all the interfaces between PLCs are serial, because you're using your PLC to control hardware or mechanical devices, and how fast are those things? They're not near as fast to justify parallel. No way. So that'll answer some of these questions right there for you. Okay.